So people can see my screen, can they?
Yeah, we can indeed.
Great. So as you know from my message on Slack, all of the content for this module will be published on this website here. And so today, what I want to do is just give you a quick overview of the module. It's always a good place to start. And then we'll get started looking at one of the kind of foundations or fundamentals for this module, which is JavaScript. We don't assume people know JavaScript, but we do assume that you are competent programmers. So we'll go through the syntax of the language fairly smartly so that we can get on to the kind of main topics. So I suppose without further ado, unless there are any initial questions that you wanted to ask me that I didn't cover in the kind of opening message that I sent to you on Slack, are there any kind of housekeeping issues, if we might put it that way, that I haven't covered that you want to ask me about in relation to the module? No, okay, so they might pop up anyway during the lecture, and that's fine. So, sorry, just go back to the website. Don't know if this way of presenting modules has been evident in the first semester. This is an in-house tool that one of our colleagues developed for, not necessarily for online delivery modules, any kind of module, but so there are various cards. And as we work our way through this module, new cards will appear. And behind each card, the kind of structure is somewhat similar. There are cards which deal with the lecture content and cards which deal with the lab content. So in my case, there's two sets of slides that I need to work my way through. I won't get through them all today by any means. And in this case anyway, there are two labs as well. I'll also publish the recording for a lecture in behind the appropriate card. So there'll be a recording card down here later on today once I've finished this lecture. Anyway, you'll get used to this way that we present this stuff as we work our way through. So as I said, for today, I want to start off by looking at the contents of these slides here. You don't necessarily have to bring up the slides yourselves, but if I clicked on that card, then it would present me with a PDF of the slides. But I guess it's probably just easier for you to just follow along with the slides as I present them here. So this is the module. Hopefully you are tuned into the right module, Enterprise Web Development. The word enterprise there is not that significant. The reason enterprise was used in the module title is for historical reasons, so which I don't need to get into. But it's very much a development or practical slant to the module, hence the word development in the title. And obviously, the context is, or the platform that we're going to do development on is the web platform. So as a one-liner, this is the objective. We want to design, implement, and deploy performant, secure, modern web apps using industry standard frameworks and tools. Now, I have kind of purposefully used a vague word there called modern. What do we mean by modern? I need to explain that a little bit to give you a more technical kind of term or context for it. We know what we mean by secure. We know what we mean by performant. I wouldn't overemphasize the importance of performant. Performance obviously is a very important aspect of any web application, but just due to time constraints, we won't necessarily get time to dig into how we can improve the performance of our web app. I can give you indicators as to where you would look all right, but we will just look at one aspect of performance improvement, which involves using caching, but that's for much further down the line. So it's got a web context, and I need to explain what I mean by modern web apps. Clearly, a web app is an app that runs inside a browser, but that doesn't tell us a whole lot about what's going on kind of behind the scenes from a technical context. So I'm going to give you context for this whole module, then we'll talk about the module itself and just some software essentials or installments that you need to take care of yourself. They're all pretty straightforward. So I used the term there in the first slide, a modern web app. So just to dig a little bit deeper into that. So web applications have been around since the beginning of the noughties, around 2002, 3, 4, that kind of area. And the way these web applications have evolved over time from an architecture point of view is what I want to get across by means of this slide and the next slide. It's a very high level overview of it now, but anyway, it'll suffice. The very first generation of web apps, their architecture followed what I am demonstrating on the screen at the moment. So on the left, I have my browser. On the middle, I have a server. On the right, there's a database. And what I want to try and get across is from this slide is that the initial architecture, which was classified as server-side rendering, even though I don't think the term server-side rendering was there at the time, it's a kind of a term that we've put on them retrospectively. But the server was doing everything. All of the functionality was in the server. And in particular, the server was actually responsible for generating the UI. In other words, the server actually generated the HTML page that it would send down to the browser. The browser would just display it. The user would typically interact with it. And any interaction that the user had with the web page, that caused another request to go back to the server, essentially asking the server, generate the new page that I should display for the user. So the user might be navigating around the app, or the user might have filled out some sort of form and clicked submit, and as a result of the submit, some new information is displayed back to them. Whatever the nature of it is, it was always the server that was responsible for generating the user interface, the next page essentially that the user saw on the screen. And the box on the left is blank, and that kind of, I want to get across the impression that we often say that the browser or the client was dumb in this architecture. It really wasn't doing anything other than displaying what the user should see, and what it displayed was dictated by the server. The server also obviously interacted with the database to get data or to store data. It may have some algorithms implemented in there to do some sort of number crunching, all of that. So this is what we classify as server-side rendering, as in the server is rendering the user interface back to the and sending it to the browser. That was the first generation. The second generation of web apps, from an architecture point of view, it gave more responsibility, if you like, to the browser. So we can see now that my browser actually does have some functionality in it. And in particular, the browser is actually responsible for generating the UI. So every time, so kind of the way it tends to work is there's JavaScript sent down to the browser, and the JavaScript that is sent to the browser, that is actually responsible for generating the various pages that this web app presents to the user as they navigate around the app. The communication between the server, the browser and the server, the purpose of that communication now is essentially to ask the server for some data, or perhaps to send some data down to the server. If it's asking you for data, then the server responds with that data, usually in some format like JSON or XML. And what the browser's JavaScript code does is it takes that data, it essentially stitches it into the next page and generates the page that it subsequently displays to the user. So what we say is that the client or the browser, it is rendering the user interface, hence this kind of categorization of client-side rendering web apps. So there's a better distribution of the overall workload in this architecture. And it is this client-side rendering model that we will be focused on in this module. Now, client-side rendering, I suppose you could date it back to the kind of mid-noughties in a way, but the actual technology that we use to produce it has evolved significantly from that time period. So the mid-noughties is quite a while back if you think about it. So it's been around for a while. Now, more recently, there is a mixture of this client-side rendering and server-side rendering, the mixture of the two approaches, but we won't get to look at that. So client-side rendering is what I'm kind of vaguely referring to in my first statement there as a modern web app architecture. And this is another look at that architecture, but what I'm trying to show here now is the fact that, so when the user kind of first launches or navigates to our web app, what actually happens is the browser sends a request to a standard web server, a standard HTTP server. And it is that server that actually contains the JavaScript and maybe some CSS and sends that JavaScript down to the browser. So now my browser now has the JavaScript code that it requires, and it executes that JavaScript code. And so the initial landing page or opening page or home page of my app is dynamically generated by the JavaScript code at this stage and displayed to the user. All subsequent interaction by the user with the app now involves this route down here. So if you like, this part of the architecture is out of the picture once the initial JavaScript has been sent down to the browser. And so from then on, once the app is up and running in the browser, depending on the user's interaction with the app, there's going to be communication between the browser and my second server. And it is this second server now that contains the algorithms and talks to the database. We refer to this server now as a web API server. Okay, the server up here is just a standard HTTP web server. It just serves static files. In this case, the static files would be, as I said, JavaScript for sure, and quite a lot of it, maybe some CSS. All it sends in terms of a HTML page is just a shell HTML page, one single page, nothing else. That is required by the browser just to get up and running. What I'm showing you here is the kind of communication flow between those three main actors in this setup, the three actors being the browser, the HTTP server, and the web API server. So again, as I was kind of talking my way through there on the previous slide, the initial communication is between the browser and the HTTP server. And essentially, the browser is asking the server for the web app's core assets, JavaScript essentially, and maybe some CSS static files. And from then on, so once the browser receives the JavaScript here, it starts executing it, and the JavaScript execution will display the opening page, as I said, to the user. And then any subsequent interaction by the user with that app will involve potentially some communication between the browser and the web API server, either sending it data or, sorry, either requesting data or actually sending data down to it. A lot of text here, which you can kind of read through yourself, but what I'm trying to get across here, I think, is that there were, I guess, three evolutions of this client-side rendering web app architecture. In the very early days, and I'm saying this is around 2004-ish, it was the very first version of YouTube was written using this architecture. Of course, it has been rewritten since. Gmail, the very first version of Gmail, followed this architecture. But the main disadvantage with the first generation of these client-side rendering web apps was you wrote a heck of a lot of JavaScript code, but it was very unstructured, highly unmaintainable, and the whole kind of developer experience I'm seeing here was very poor, just because of the sheer volume of code that you had to write. There was no best practice in terms of how you should structure that code. So there was a lot of code bloat. Also, I'm saying that the very first generation of these client-side rendering web apps, they lacked addressability. Now, what I mean by that is when the user navigated around the app and different pages appeared in the browser to the user, the URL in the browser never changed. We know that addressability is one of the core principles or qualities of the web. If you go back to the very first generation of the web, where we had static web pages and we had hyperlinks, and we know that every time the user clicked on a hyperlink, the page they saw changed, and also the URL in the browser changed. So each single page had its own unique URL, i.e. its own unique address. That characteristic was lost in the very first generation of these client-side rendering web apps. Yes, the user saw different pages, but the URL in the browser never changed. So that was a real weakness. Around 2006, this library, and that's all it was really, a JavaScript library called Jquery came on the scene. And what Jquery solved was this part of this first problem up here. Jquery significantly reduced the volume of JavaScript code that you had to write as a developer. And also Jquery solved the problem that, that you had back here, which was you had to write your JavaScript code, and the JavaScript code had to determine what the execution environment was. In other words, which particular browser am I running in? Because the code that you wrote tend to vary from browser to browser, or you had to write your JavaScript so that it could deal with different types of browsers. Jquery kind of took care of that problem. So it made your client-side rendering web app browser agnostic, or it could run in any browser without you having to take care of having to build that into your code. So it had that main advantage. It was a better developer experience, and it reduced code bloat. That's okay. I don't think I mentioned the browser quality there, but that was another main advantage of Jquery. We still had some disadvantages though, which was the addressability. And also as well, the code was still, there was no best practice in terms of how you should structure your code. So it was highly unmaintainable. Then another technology evolution came along, which kind of has an odd name, but we'll understand the name maybe a little bit later on. Single page app frameworks came on the scene. They started to emerge around 2010. And they solved the addressability issue, and also they solved the developer experience problem. They actually enforced a kind of structure on your code based on good design patterns and best practice that was learned from the earlier generations. And this is kind of where we are now, right? We're in this era of single page app frameworks, and we will be looking at a particular single page app framework in this module. So that's kind of by way of the history of these client-side rendering web apps, how they've evolved since the beginning of the century, really, if you think about it. That's my way of giving you context for all of this. Now, where is this module coming into this whole area? Well, if I go back to this diagram, there are essentially going to be two parts. When you're developing a client-side rendering web app, you have to develop client side and you have to develop the web API side. So for this aspect of it, for developing the client part of it, the browser part of it, we will be using a single page app framework called React, which you may have heard of. In very simple terms, all React is just a JavaScript library for building user interfaces. Sounds fairly trivial, but it's a fairly significant piece of technology, and we certainly won't get to cover it in its entirety, but we'll certainly go a good way into getting you up and running using this React framework. It's been around since about 2012, 2013, and it's extremely popular in the industry. Then for the web API side, we will be using a technology stack comprised of Node, which you may have heard of. Node is a platform for executing JavaScript code outside of the browser, or as we say, on the server. And we'll also use a library called Express for developing our web API. From a database point of view, we could have picked any database really, but we will use one called MongoDB, which has grown in popularity in the last 10 years or so. It's a non-relational one. You may have heard of it as well. It's a non-relational database. So it kind of broke the mold in the database world. We also may come across something called REST when we're looking at the server web API development side of it. REST is essentially a design approach, or a way towards approaching the design and implementation of your web API. So this is another way of looking at what we will be covering in this module. So on the left, I have my browser. The middle is my server, which we now know will be running what's called a web API. And on the right is my database. And based on the technologies that I mentioned on the previous slide, what we will be using overall is what's called the Mern Stack. This is just an acronym that has popped up over the years, so the recent years. So Mern stands for, or the individual parts of it stands for MongoDB, Express, React, Node. That's where it comes from. So this is our technology stack, if you like, for this. We could have picked, there are many other technology stacks, but I would arguably this is the most commonly used in industry. And what's nice as well is it's really going to be JavaScript, both on the client side, on the server side, and really MongoDB is essentially a database of JavaScript objects. So it's JavaScript from end to end. Obviously, the client has to be written in JavaScript because that's all a browser can execute. Now we'll just conveniently ignore WebAssembly, because we now know that WebAssembly allows us to write non-JavaScript code that will run inside the browser, but we'll, as I say, conveniently ignore that. The browser can only run JavaScript, so we have to pick JavaScript there. We could have picked any programming language for. We could have picked any programming language for the web API.
Let me introduce my
maybe Python.
A lot of openings in the machine learning field. So every company is trying to use machine learning to understand and get gems from their data. They have a data, but they don't know what to do with their data.
That's something in the background. Sorry, is there? Sorry, does somebody have? Okay, it's gone. I hope. Okay. In the from the web API side, we could have picked any language or any platform. Like we could have picked Python, we could have picked Java, we could have picked .NET, but we've just decided to go with Express and Node because that means then we can use JavaScript on both the client side and the server side, so you don't have to be learning or balancing two languages in one module. And MongoDB, I've kind of already spoken about that. So it's nice that we can just use one language for all tiers. What I'm showing you here is, or what I'm trying to get across is that the technologies that we will be using are industry standards. This is a survey, a global survey of the most popular web frameworks. Both there's a mixture here now, kind of client side and server side in this graph. But what it is telling us, and I think it's the first year that React has actually become top of the list. It was second for quite a while. Jquery was number one. So React is the most popular web framework being used in industry. And you can see Express is quite high up there as well. So that's by way of justification, if you like, for choosing the stack that we are going to use. This is a very, very, very kind of high-level outline of how we're going to progress through this module. Initially, I want to cover some fundamentals, and really there is only one fundamental, and that is the JavaScript language. So as I said at the outset, we'll assume people don't know JavaScript, even though many of you may already have some experience of it, but we do assume that you're competent programmers, so we will get through that fairly quickly, like maybe this lecture, the next lecture, and it should be finished up by then. Then we will move on to this section here. We will build a client. We will start using the React framework to see how we can build the client side of our architecture. And then we'll move on to developing the web API part of it and integrate them, obviously. I should have taken out this bit here. We won't be covering any agile practices because we just won't have time to cover them. So that shouldn't be in the graph. Maybe I'll just pause for 1 second. I know I'm ripping through it fairly quickly, but just in case there are any questions arising from what I've talked about so far, are there, I wonder? No, just in general anyway, feel free to butt in at any stage if you have any questions. I won't be offended if you just start talking out all of a sudden, so that's fine. Feel free to butt in at any stage. So that's the module focus. We'll be looking at a single page app, and in particular, we'll be looking at React to develop our client side, and from the web API side, we'll be using Node and Express. In terms of what software do you need to install, I am going to be using VS Code as my text editor. Again, it is almost an industry standard at this stage. It is extremely important. It's not mandatory for you to use VS Code, but I would encourage it because, as I said, it's extremely popular in the industry. So it would be good just to be familiar with the IDE. But if you want to work on another IDE when you're doing your own development for this module, that's fine by me. I'll be using it throughout though. You need to install Node.js. You may already have it. If you're installing it for the first time, then just go to the website that I'm showing you here and make sure you pick the one here on the left. Do not pick the version on the right because the version on the right is experimental. So make sure you have this one. And if you have Node already installed, and if it's quite old, it might be a good idea just to upgrade to a newer version. We will be using Git as well. In the background, really, we don't cover Git formally with you. Any Git commands that you need to be familiar with, we will use them extensively in the labs. But if you know Git already, that's great. If you don't, maybe just spend an hour or two just doing a quick read up on it. We won't be covering it formally, as I said. But you do need to have Git. I suppose from a software installation point of view, you do need to have Git installed on your machine, and it more than likely is already installed there. So just do the usual thing of from the command line, git -v or -- version. And if it comes back with any kind of installation, that's fine. Again, it doesn't really have to be an up-to-date version of Git. As long as you have an installation, it will suffice. You need to be familiar with issuing commands from the DOS terminal or from your shell window, because we do it quite a lot. So I'm just assuming people are going to be comfortable navigating around directories from the shell or DOS window. VS Code actually, you know, when you start using VS Code, you never really have to leave it. You know, it has its own what's called an integrated terminal. So you can actually execute terminal commands or shell commands from within VS Code. You don't have to open up a separate shell window, issue your commands from there, and then come back to VS Code. And you see me doing that in these lectures as well. Just finally, there is this kind of term now that has emerged over the last maybe 2 or 3 years called a full stack developer. And really, it's a bit of a misnomer. So people say there's no such thing as a full stack developer, but it is a term that you see often in job adverts. And really, all a full stack developer is someone who has knowledge of all layers or tiers of our client-side rendering web app. In other words, they have experience of the client side, they have some knowledge of or understanding of how to do the development on the server side, and they have knowledge of the database side. we won't be full stack developers at the end of this module, but we certainly will have an appreciation of all of the layers. The majority of our time will be spent on these two here. We kind of assume people are familiar with databases and the fundamentals of databases. You may not be familiar with MongoDB. You may not be familiar with NoSQL databases. So you will get exposure to that. But outside of that, we won't spend a whole lot of time covering the fundamentals of databases. But that's what full stack developer means, that you are competent in all layers of the architecture. So that's, you can read through the summary yourselves. I suppose an obvious question that people always want to know, and for very good reasons, I suppose, is how is this module assessed? It is 100% CA assessment based. There will be 2 assignments, and one assignment will involve developing a React app, and the second assignment will be to develop a web API that integrates with that React app. What we will do in the labs is we will roll out a React app and the web API for that React app. That's what the labs will primarily involve. Not this week. We won't begin this week. It won't even begin next week. It'll be the week after. But from week 3 onwards, we will be rolling out a web app comprised of a React front end and a Node Express back end and a MongoDB database. And what we ask you to do then is to take the app that we develop in the labs and extend it out further, add more functionality and features to it. That's what the majority of students do. You can, if you want to, take a completely different starting point, or start from a without any basic app or base app and develop it out yourselves. But I guess that's a little bit down the line, really, before you can make that kind of decision. The front end, the React app is, I think the way we split it up was a 60-40 last year, but that's we may change that weighting this year.
Dermot?
Yes.
Are the labs mandatory?
They are, yeah.
But the timing wise, if I have the labs completed and made available somewhere beforehand, is that okay?
You mean if you have the labs, if you complete the labs beforehand, is it?
Yes, or is there a way of tracking that I've done the lab? I know that Eamon's front end thing there used to have a GitHub login, but it doesn't seem to have it anymore. So
okay, I don't think, given that you're postgraduates effectively with our undergrads, we would require people to show evidence that they worked their way through the labs. I don't think we will require that of ye, but and I don't doubt that you will work through them yourselves in your own time, although I'll only reveal the labs on a kind of a week by week basis. I won't reveal all the labs or make them available to you like from today onwards, so that you can work through them at your own pace. That's point number 1. Point number 2 is more than likely, as I was saying there, you will need to have completed the labs before you can start working on the assignments.
Yeah, but that's no issue. So if no, it's just sometimes I have a meeting on Thursday afternoons.
Oh yeah.
And I won't be able to get to some of the labs at those times or whatever.
That's fine. No,
yeah.
That's fine. You essentially you do them in your own time. Once we publish a lab, then you work on it at your own time. We just make ourselves available between those 2 hours on a Thursday, and people may not have any questions then, but the questions may arise on later on. And as I said in the message last week, you can post messages onto the Slack channel outside of those hours. Other people in the class may have already come across the same problem, and they can volunteer their solution, and I'll just check it every now and again. We're liberal enough in that sense.
That's perfect. Thanks, Millie.
Great. Anything else, I wonder? No. Okay, let me just check my watch. Right, let's go back to the website. And so we've covered our overview. And I need to go into the first lecture now and start looking at the JavaScript syntax. Close off these. Okay, so this is by way of a review, I guess we call it, of the JavaScript language. Just 1 second now, sorry, I need to. Right, I'm going to give a very quick background to the language itself. I won't bore you with that kind of stuff. Then we'll get into how we represent state or data in JavaScript, and then move on to how we represent logic or behavior. I won't get to the behavior part, I don't think anyway, today. So it'll be mainly looking at state representation in the language. JavaScript is the most popular language, and this is a survey from that GitHub publishes every year. It's called the Octoverse. Not sure where they get that name from. Octoverse survey that they produce each year, and what it's telling us. And there are a number of aspects to the survey, but one of them is the popularity of languages out in the industry. And for a number of years now, I think about 8 years, JavaScript has been the most popular language, as reflected on the activity on GitHub anyway. And hence, it's an extremely important language for any software engineer to have as part of their toolbox, if you like. Similarly, Stack Overflow survey every year, and it's telling us a similar kind of story, that JavaScript is, for this year anyway, and for the past number of years, JavaScript has been the most commonly used language amongst the people that responded to the survey. The GitHub one, I think, is more based on activity on GitHub itself. It's not that they survey people, they just analyze the various repos on GitHub to get a sense of what languages are being used. So both surveys stroke analysis are telling us the same story. It's extremely important to have JavaScript as part of your knowledge base. The only thing, there's a lot of text here, but the main thing I want to get across here is the link between JavaScript and something called ECMAScript, I mentioned here. ECMAScript is the specification for the JavaScript language. I'm sure you know by now, if you read anything about JavaScript, that it was designed by this guy called Brendan Eich, and it's kind of folklore at this stage. The language was actually designed and implemented. It varies. Some say it was over a weekend, some say it was over about a week or 2 week period. Either way, it was a mammoth effort. He's the guy that actually designed the language based on he was influenced by a number of languages there, Java, Self, and Scheme. Self is an object-oriented language, never really made it in the language world. Scheme is what's called a functional language. That's mainly the preserver of academic institutes. Java, of course, you know. He designed the language, and he essentially handed the language over to the ECMA organization, ECMA standing for the European Computer Manufacturing Association, which is essentially just a body that provides standards or maintains standards for various aspects of the computer industry. He gave the language to them, and what ECMA did was they abstracted from the language a specification. So the language came first, the implementation came first, and then the specification, which is, it's usually the other way around. They call the specification ECMAScript, and they evolved that specification over the years. And I'm showing you down here how it evolved over time. So the very first publication of the ECMAScript specification, which was called ECMAScript 1, ES1, was around 1997. And then they upgraded it year on year. Now, at one stage, it was felt that the language was going to die. You can see here ES4 was abandoned, right? And it was felt that the language really wasn't going to make it as a useful language to the community. But it resurrected itself again in around 2009. Now, there is something significant about 2009. 2009 is actually when this Node.js platform came into use by the community. And what Node is a platform that allows you to execute JavaScript outside of the browser. Prior to 2009, you could only execute it within the browser. So it had a kind of a limited use prior to 2009. But with the emergence of Node.js, the ECMA organization decided that they would resurrect the ECMAScript specification, and they published what was called ECMAScript 5, ES5. And from then on, they have upgraded the specification year on year. So we get ES6 in 2015, which is also a very significant one, ES7 in 2016, and on it goes. I think they're kind of referred to as ES year now rather than ES kind of numbers. So you get ES 2018, ES 2019, and so on and so forth. Now, the two significant versions of the ECMAScript specification is ES5 and ES6. We tend to talk about the JavaScript language pre-ES6 and post-ES5. There was a lot of changes made in the specification for the language in the ES6 specification. In particular, for example, they introduced classes to the JavaScript language, which didn't have it prior to then. Now, oddly enough, all the JavaScript that we do in this module, we won't actually use classes at all. There's a lot of people in the JavaScript community who feel that classes are not a very useful addition to the language. The main reason classes were added was to satisfy mainly kind of Java programmers and all the other programmers that were used to object-oriented languages. Technically, JavaScript is not an object-oriented language. It's more a functional language. So every now and again, I'll make reference to ES5, ES6 in our discussion of the language. So the link between JavaScript and ECMAScript is really the important message that I want to get across in this slide here by way of background. And carrying on that idea, when you run JavaScript in a browser, all browsers, especially the old browsers, they cannot run JavaScript post ES6 JavaScript syntax. Each ECMAScript specification introduced some new syntax to the language, and browsers that predate that kind of 2015, and they're still out there, they cannot run ES6, ES7 JavaScript. They can only run ES5. And so when we write JavaScript code that we want to run in a browser, and presumably we want to run in any browser, then we've got to ensure that the JavaScript that we write is ES5. But that means then, well, does that mean we can't really use the newer syntax? And this is where transpilers come in. A transpiler can take modern JavaScript, i.e. ES6 plus JavaScript, and convert it into back to ES5 JavaScript. There is, fortunately, there is one dominant tool in this transpilation field, and that is a tool called Babel, which I mentioned somewhere here. There it is there, the Babel tool. And we will be using Babel throughout this module, but it's in the background. We never need to worry about it. It's just there. So what Babel does is it takes modern JavaScript, i.e. ES6 and beyond, and converts it back to ES5 syntax. We never need to look at the ES5 syntax. We write our JavaScript using the modern syntax. If you're very up to date with JavaScript, you may know that there is now actually an alternative to Babel called SWC, but we won't be using SWC. So transpilation is something that is necessary, but it's something that happens in the background for us, and it's necessary to ensure that our JavaScript code will run in any browser, not just the modern browsers. Obviously, the modern browsers can execute ES6 syntax, maybe ES7, and even more recent than that, but we can't restrict ourselves to that. Just a word about the semicolon. So we haven't looked at any JavaScript syntax so far, but if you're coming from a Java background, you know what the purpose of the semicolon is in the Java language, and it is a statement terminator. You've got to have a semicolon at the end of each statement, and that helps the Java compiler to work out where statements end when it's doing its compilation. Of course, JavaScript is not compiled, it is interpreted. Now, in the early days of JavaScript, the semicolon was essential because that told the runtime interpreter where a statement ended, so that it could then, the interpreter could then begin to evaluate the statement and execute it. But we no longer really need to include the semicolon in our code. It's now optional at this stage. Although the Babel tool that I mentioned there, which takes our modern JavaScript and converts it back to ES5, it actually reinserts the semicolon back into the code for us. It performs something called ASI here, automatic semicolon insertion. So what you will see in my JavaScript code is sometimes I'll have a semicolon at the end of a statement, and sometimes I don't. And really, it's just absent-mindedness or laziness on my part as to whether I do or I don't put it in. But it doesn't need to be there at all. We don't ever have to physically type the semicolons. There are very extreme cases when you would actually need it, which I'm just mentioning here for completeness sake. If you've got a multi-line statement, then it may be better that you do include the semicolon, but we won't, I don't think we will be writing JavaScript code that is so complex that we will need to be aware of that. So for now, the semicolon is optional. And anyway, even if you leave it out, once the Babel tool takes your JavaScript code and converts it into ES5 JavaScript, then it will actually reinsert it in for you anyway. That's background. Now, let's start looking at the syntax of the language. And first of all, I want to look at how we represent data. Any modern language has to have the ability to represent primitives, and JavaScript is no different. And the types of primitives are all the things that you'd expect. So we have number primitives, string primitives, Boolean primitives. We have the null value, which is similar to null in Java. And we also have this peculiar primitive called undefined. And it arises in on two occasions. If you declare a variable and you don't initialize it, then by default, it's given the undefined value. So undefined technically is a value that is assigned to a variable. And it is assigned to that variable if you don't explicitly initialize it. But it is a value as such. It's not a very useful value, but it is a value, and it is different from null. It's one of the peculiarities of the language, really. JavaScript has a number of peculiarities associated with it. And that kind of goes back to the fact that it was designed by Brendan Eich over a very, very short period of time. So it has quirks in it for sure. Undefined is arguably one of them. Now, apart from primitives, if you want to represent any kind of complex data in JavaScript, then you have this construct called an object, which is different in some ways and similar in other ways to an object in a conventional object-oriented language like Java. But we'll come on to objects in a little later on. But it's from a JavaScript perspective, an object is this construct that you use when you want to represent non-trivial or complex data. JavaScript is a dynamically typed language. That means when you declare a variable, you do not have to declare what type it is. Its type is inferred from whatever you assign to it. That can be a very powerful feature. That can also be a very dangerous feature. But strictly speaking, when you declare a variable on one line of code, you could assign a numeric value to it. And on the next line, you could assign a string to it. So you're essentially changing its type dynamically within the runtime. As I say, that can lead to very powerful features of the language, but it can also result in a very buggy kind of language. Now, to work my way through some of the fundamentals of data representation, I just have a series of little sample JavaScript scripts, and you will work your way through these in the lab as well. The first lab involves using the samples that I will work my way through in this lecture and perhaps into the next lecture. So the way it works is, I'll just show you how we set it up, and you will be doing this yourselves in the lab, as I said. So let's suppose we have installed VS Code and we start it up. And so this is how VS Code will look. Now there's something popping up on my screen that I want to try and get rid of. If you just give me 1 second to see if I can get rid of it. Sorry, no. Good. Right, back to here. Here's my VS Code, and I have a folder with some JavaScript code in it that I want to import into it. And importing is pretty straightforward. So here's the folder that contains some sample JavaScript code. And all I've really got to do is just drag it across to VS Code, and that's the importation taken care of. So here is just a series of simple JavaScript files. If you haven't used VS Code at all, then on the left here, we have what VS Code calls its activity area. The two main activities are this one up here, which is Explore, which is the activity that you will enable when you're just doing any kind of normal editing. If I just open one of the files, for example, then here's my editing area here. The other one is this one here. If you want to do any Git related stuff, you click on that to get into your source code activity. But the one that you'll mainly be working at for this week anyway is just this one here. So make sure it's selected. If you want to install additional plugins, which you will need to for this very first lab, and I explain how you do it in the lab, but essentially you've got to come down to this activity here. When you click on that, what it shows you are all of the plugins that you have installed, and it actually shows you other plugins that you potentially can install. And you can kind of do a search. So it's actually communicating. It's getting this list here. Sorry, now I just pull that up a little bit. This bottom list here, it's getting from a remote repository. These are the ones that I actually have installed at the moment. And if you want to search for a plugin, if you know about a plugin and you want to install it, all you've got to do is type part of the name of the plugin here at the very top left. So there's one that I need to use for this very first lab, and it's called Live Server. So if you just Start typing the name of the plugin, it will find matches in this remote repository that has all of these plugins. And this is the one that I'm interested in for this lab here, live server. Now I have it already installed, but if you did not have it installed, there would just be an install button over here and you just click on it and it installs it. It's as simple as that, really. What live server is a standard HTTP server, snitting fancy. So you can do that in your own time. When you have that server installed, here's how you use it. So if I go back to my Explorer activity, and if I open up you can see here what I've got is an index.html page, and I've got various JavaScript scripts. And there's nothing in the index.html of significance other than references to various script files, which I will enable and disable as I work my way through these. Now, having opened up index.html, down at the very bottom right here, there is a link called Go Live. This link was put there by this live server VS Code plugin that I was just talking about. And when you click Go Live, what you are essentially doing is starting the live server HTTP server. And it will serve whatever HTML page you're currently looking at within your IDE, within your VS Code. So if I just click that, the live server kicks off and it opens up a tab in the browser and it displays the contents of the current page that you're looking at. And there's very little in that page. If we go back to it, you know, the only thing that appears is this header here, nothing else. We're not really interested in the web page as such. What we're really interested in is the JavaScript that might be executing behind this page. Now, at the moment, there isn't any JavaScript because I've disabled all of these. If I just uncomment one of these and uncomment it, when I save this change, what the HTTP live server will do is it will push the updated page to my browser tab. And of course, what's going to happen now is not only will the contents of the page change in the browser, but it's also going to request this particular JavaScript file from the live server because I've enabled it. Like if I change just the actual text here, something's senseless. If I save that, go back to my browser, you can see that has changed, okay. But as well, the JavaScript file that was being referenced from the HTML page, that's also been downloaded to the browser and it has executed in the browser. Now, the only way I can prove to myself that it has executed is by opening up the browser's developer tools. And so to do that, if you're familiar with, by the way, I will be using Chrome throughout this module. And so you should get used to it as well. So the developer tool you access from here. Again, you may be already familiar with this, so apologies if this is a bit too trivial for you. And make sure you set the console tab within the developer tools, and any console output that your JavaScript code executes, that will appear here. So let's see what is in this file. So I enabled a reference to 0.1 primitives, and if I look at 0.1 primitives, it's a pretty trivial stuff now. Okay, so I've got some console output here and here, and that looks like what is being displayed by from these two here. So what I want to do is really just talk through some of those JavaScript scripts and just so that we get an understanding of the basic syntax of JavaScript in terms of data representation. So again, you will have to go through the setup yourself. I kind of step you through it in the lab. So you should get to the stage in the lab where you have you've the live server installed, you've kicked it off, and you can see evidence of it in the browser. You have the developer tools open up on the right in the browser so that you can see what the various scripts are producing in terms of output to the console. Back to my slides, I'm talking about data representation and some of the basic syntax. So this screenshot is actually showing me the contents of that 0.1 primitive JavaScript file. And really all I'm showing you here is how to declare primitive variables. So there's this keyword let, followed by the variable name and whatever you've assigned to it. As again, I say, it's pretty standard kind of stuff. Now, is there anything to be, so that's what I have in my source file. I'm just going to collapse that for now. So that looks fine. Look here, I'm just declaring a variable called foo1. I'm assigning it a value 5. I'm not saying what type foo1 is, but clearly foo1 is going to be a numeric type. Foo2 is going to be a string type. Foo3 is going to be a Boolean. These types are inferred from the runtime. Foo4, I'm assigning it null, so it has no type as such. I've been using let here for all of these variable declarations. Now I change to const as in my variable declaration. So the question is, what is the difference between a variable declared with let as opposed to one that's declared with const? When you use let, what you are essentially saying is that this variable, its value or its assignment will change within the body of your script. Or in other words, you can reassign a different value to the variable. Whereas when you declare a variable with the keyword const, then you are saying it cannot be reassigned subsequently. Whatever value you give it initially, that assignment cannot be changed, i.e. it is a constant. Const and let are part of ES6. Previously, we just had a keyword called var for declaring variables.
Dermot?
Yes?
Can we use let and var interchangeably in this module, or are you going to want us to use let?
I would get into the practice of using let because var probably won't arise with G, but the difference between var and let has got to do with the scope of the variable, which I think I mentioned in a second. So I would get into the habit. Look, if you accidentally use var, we're not going to come down on you like a ton of bricks. But I would get into the habit of using let and const. Really, it would be bad practice, I suppose, with a small emphasis on that, to be using var. But if you do it accidentally, it's no big deal.
No problem.
So primitive types, let's already explained. It's the way we indicate to the interpreter that we are declaring a variable. We obviously have to give the variable a name, i.e. it has to have an identifier. There are various rules as to the structure of an identifier. They're all fairly standard kind of things. I'm not going to go into them. The operators, there are various operators. The operators are all of those operators that you're familiar with from other languages. What else am I seeing here? Some rules about where, well, okay, that's all right. So that's fairly straightforward stuff. The difference between let and const, I've already alluded to. Now there is an odd thing about const that we'll come across a little later on. But like if you're lazy, which I often am, you can use let for everything. The difference, the idea behind having two different ways of declaring a variable was more to give an indicator of the programmer's intent. So when you're reading somebody else's code and you see a variable declared with let, then that should tell you as the reader of the code that this variable will be could be reassigned a different value later on in the execution. Whereas when you see variable declared with const, then that tells the reader of the code, well, this variable is never going to be reassigned, i.e. it's going to be constant. So it gives the reader an indication of the programmer's intent when they were writing the code. There are probably other advantages behind the scenes to using let and const. So as I said, if you are very lazy, you could just use let for everything, even though you know that the variable isn't going to be reassigned. But try and get into the habit of using these two in the way that they were intended. I'm pretty sure that in my code, I use let sometimes when I should have used const. So we all fall into that trap. This is kind of back to the question that you just asked me there. Both of these variables, whether it be a let or a const variable, they both have what's called block scope. A block is any segment of code that is enclosed in these curly braces. Again, if you come from a Java background, you know that curly braces are used a lot within Java for encapsulating a block of code. We use it to encapsulate a class. We use it to encapsulate a method. We also use curly braces to encapsulate the true and false side of an if-else statement. Well, the same really applies to the role of these curly braces in JavaScript. They encapsulate a block. So any variable that you declare inside a block is only accessible within that block and not outside of it. To go back to the question there about var, if you declare a variable with var, then it can be accessed outside a block. And that's where things may get tricky for very involved code. So block scoping was introduced in ES6. Prior to that, JavaScript followed what was referred to as function scoping. And really, that's it really with regard to primitives. That's how we declare them. Flip back to the code. That's how we declare them, how we initialize them. The only other thing maybe that I should just mention is, well, sorry, if we take this line here, I'm reassigning a different value to foo2. Obviously, I don't use the keyword let here because foo2 has already been declared. So that's just a standard reassignment statement. Foo2, if you look up foo2 was initially, it was assigned a string, and now I'm assigning it a numeric value. And that's an indicator that JavaScript is dynamically typed. Now, it may also reflect poor design on my part if I assign different type of value to a variable from the type that it was initialized to. You're better off really to not overuse this kind of dynamic aspect of JavaScript. It does kind of reflect poor design on a programmer's part. But from a technical point of view, you can do this. The only other point as well that I want to make is, let's say if we take this line here, I'm declaring a variable, but I'm not assigning it a value. And what we know from now is that that variable foo5 is going to have the value undefined. So the console.log here of foo5, if we look at it that's where this undefined is coming from. And that's about it really with regard to primitives. Nothing too exciting there. The more exciting part, if there is an exciting part to data representation in JavaScript, is the role of objects. So I'm saying object is the fundamental unit of composition for any kind of non-trivial or complex data. And or if we want to represent state in our code. And if we kind of fast forward down to here, here's the syntax, or here's an example which demonstrates the syntax of objects. So we actually do use the curly braces. Normally curly braces relate to encapsulating logic, but we actually use the curly braces to encapsulate an object in JavaScript. And an object is made up of what are called key value pairs. So I would say first name is a key. Dermot is the value for that key. Last name is another key, and O'Connor is the value for that key. So an object is a collection of key value pairs. A key and a value combined is referred to as a property. So I would say that the me object here has two properties, the first name property and the last name property. So that's the terminology that we use in relation to objects, keys, values, properties. And we enclose our object in curly braces, and we separate key value pairs with a comma. The value can be of any type. It happens to be a string here. It could be numeric, could be a Boolean, could be null, or more interestingly, the value could be an object itself. And so you can have objects nested within objects. And that's really what we will see a lot of throughout this module. So if I have an object structure declared, how do I access individual values within that object? And so there are two notations available to me. There's the dot notation. So an example of it is here, me.firstname. Me is referring to that object that I had on the previous screen. And we know that first name was one of the keys within my object structure. So this expression, me.firstname, that's going to evaluate to whatever value was assigned to first name, which was Dermot, if you remember. Alternatively, we can use what's called the subscript notation, which is I'm illustrating here. And we use the square brackets, which is the standard kind of subscripting syntax that we have in in lots of languages. And we, within the subscript square brackets, we specify the key that we are particularly interested in. And note the key has to be a string. Okay, so we have to put be they single quotes or double quotes, it doesn't really matter. But we specify the key as a string. If you leave out the quotes here, then you're just going to get a runtime error. So that expression also evaluates to Dermot according to the previous slide. So we've got the dot notation and the subscript notation. In many cases, it's a question of style as to whether you use one or the other. In some cases, though, you have to use one particular form of dereferencing because the other one won't work from a syntax point of view. We'll see that a little bit later on, maybe. But in general, you can use either or, whichever you're used to, and you can combine them. It's the same syntax that we use if we want to change the value associated with a key. So here, the me.firstname is appearing on the left-hand side of an assignment statement, and the effect of this entire statement here is to change the value associated with the first name key, change the value to Jeremiah. Similarly here, but in this case, I'm deciding to use the subscript notation to change the value associated with a key. Apologies if you don't have Gaelic as part of your language. O'Cruhur is the Gaelic for my name, O'Connor. I should have made it something else really, but anyway. So it's the same dot notation, subscript notation, whether you want to refer to a particular value or change a value. All right, here's the one of the catches with const. I'm saying objects declared with const are mutable. Now, the impression I gave when I started talking about const first is that if you declare a variable using const, then what you're saying is it cannot be reassigned a different value. That still applies. However, if the value that you are assigning to your variable is an object, then the particular key value pairs within that object, they can be changed or mutated to a variable that's declared with const. What you cannot do is assign a completely new object to a const variable. That catches people initially, and admittedly it caught me out initially, but there you are. So you can change the individual key value pairs within a const variable, but you cannot reassign a completely new object to a const variable. Okay, so we're totally look at sample 2. So the way you kind of work these samples now, if you want to work your way through them, is you go to your index.html. Now my live server is still running in the background, and I'm going to comment out this line. And I'm going to enable this line. So whatever is in the 02 objects scripts, and let's just take a quick look at that. And I am declaring an object here with lots of details that are not true about me. I am not 21 years of age. I do not have that bank balance. Okay, it's the same old joke every year. So sorry about that. So it's an object anyway, set of key value pairs. And I'm just demonstrating dot notation and subscript notation. So I'm doing a console.log of me.name. And I'm tagging it along. And here I'm using the subscript notation. I'll come on to this in a second. So just go back to my index.html. So I've changed my index.html. And once I save this change, then my live server will update the browser essentially. So if I do that, go back to my browser, what it's showing me here now is because I've opened up the developer tools, this is coming from the various console.logs of the 02 script. So if we look at the very first one, Dermot O'Connor lives at 1 Main Street. So that line came from the first console.log, which was this one here. Yeah. And what I'm demonstrating down here actually is, so I'm just declaring a standard variable here called BB, which is not a very good name for a variable, but just bear with me. And I'm assigning it just a string, just a standard string. Now, it happens to be that that string does actually match one of the keys in my object. And when you've got that, you can use the subscript notation without the quotes. So if you see, where have I got it here, right? I've got me subscript BB, but BB is not inside quotes now. BB is just a variable. So what happens at runtime is the runtime will see that BB is a variable reference. It will go looking for the variable and it will find that BB is assigned the string that, and it will simply substitute the string bank balance into this expression here. So that now becomes a valid expression to dereference a particular part of my object. So me.bb will output this value here, 20.2. An error would be if I put quotes around BB. What do you think is going to happen?
It'll throw an error.
Right, it'll throw an error. In fact, you remember I mentioned this undefined value. There are two cases when undefined is outputted, if you like, at runtime. One is if you just declare a variable and don't initialize it, then by default, that variable has the value undefined. The second time it arises, and you will come across this quite a lot, is if you try and access a key within an object that does not exist. If you try and access an invalid key within an object structure, then that expression will evaluate to the value undefined. So me subscript, the string BB there evaluates to undefined. And I can just prove that to you if I save that change and go back to what's outputted. You can see here, it's this here. So it's not an error as such at this stage anyway. It's an actual value. It's not a very useful value, but it doesn't crash my program because it looks like that the subsequent console.log still executes. Okay, so you can use variable names within when you're using the subscript notation. Now, what will not work either, though, is if you try to do this. Sorry, where's my line of code? If you sorry, if you use the dot notation, so if I go me.bb, that's not going to work either, because now, just as our previous example, it's now going to go looking for a key called bb, which doesn't exist. And that again, me.bb is going to evaluate to undefined. So I said there that it's really a question of choice as to whether you use subscript notation or dot notation. Well, for this particular example, the only option you have is to use the subscript notation, which is the way I had it originally. You cannot use the dot notation if we want to use this bb variable. Yeah. So where are we? Yeah, we've covered all of that, I think. Some other characteristics of objects, I'm saying that they are dynamic. By that, I mean, you can at runtime add new properties or remove properties from an object at runtime. You do not have to, when you declare the object, you do not have to have all of the key value pairs in the declaration. They can be changed at runtime so that the object can expand or contract. And so by way of example, we're told to look at the 03 script. I won't go through all of these now because it'll just be too slow. But if I go back to my index.html, disable the reference to script 2, enable 3, save that change. What's it asking me that for? Sorry, save the change. And let's just quickly open up 03. Again, I've got the me object again. And here, if we look at this expression here, I've got me.employer equals WIT. Now, if we look at the object up here, I don't have a key called employer. So the effect of this line here is to add a new key value pair to the me object. And how do we remove a key? The syntax is a little bit ugly, but that's how you remove a key value pair from an object. Hence, our objects, I'm saying, are dynamic, and you can look at how what that generates in the browser yourself in your own time. The next point is that objects can be nested, and this is where it kind of gets interesting. You can have objects as the value of a particular key within an outer object, if you like. And you can have any level of nesting that you want to. So a property value may be another object. If we're told, look at sample 041, and then we'll just look at the code rather than necessarily run it, because you can do that yourself. So my me object now, it has a key called name, but the value is, as we say, an inner object. Similarly here for finance, the value is an inner object as well. And we've got nesting, and you could have the value for any one of these keys could also be an object. So you can go to any depth that you want to. What you've got to be careful about when you've got nested objects is that you use the dereferencing syntax carefully. Initially, anyway, you have to be careful about it. After a while, it just becomes second nature to you. So if you kind of see this expression here, me.name subscript first. Well, the expression me.name, that's going to evaluate to this entire object. And then the subscript first is obviously going to pick out, this value here. Typical kind of mistakes that you might make as a beginner is, you don't put a dot there because that's now invalid syntax. Or we've got another example over here, have we? Here we're just using the subscript notation twice. You don't put a dot in there. So it's a question of just getting used to the syntax. And you can mix and match them any way you want to. So instead of doing subscript bank there, I could have said dot bank. And that's going to work as well. So you can mix and match them. Just pause for a second in case there are any questions so far. I know I'm going through it fairly quickly, but hopefully it should be okay for you. Maybe not, I don't know. No questions, okay. Property value can be a variable. We've kind of already had that, but the last point here, sorry, a property value, it can be a variable reference. Total look at 042. If we just take a quick glance at 042. So I've got this object here called name, and down here I've got an object called me, and you can see this line here. Name here is referring to the object up here. Now, there is I've told you that the ECMAScript specification kind of evolves over time and the language kind of follows on from that. There is actually a shorthand version. When you've got a case where the key and the value are the exact same, you can actually now do this. That actually evaluates, that expands at kind of runtime. Sorry, when this code is transpiled back to ES5, it's transpiled back to that. But as the programmer, you can write it in shorthand. You can write it like that, and it will work fine, provided you're using Babel behind the scenes to transpile it back to the kind of fuller form of it, if you like. And you will see me doing that every now and again. So if you see that, that's really what we're trying to do here. We're saying that the key is called name in this case, and the value is also called name, where presumably the value is a reference to a variable called name that's declared elsewhere. So that's just one example of how the syntax of the language has improved arguably over time. It's become kind of cleaner and less physical typing from a programmer's point of view. So that's 042, and again, you can look at that yourselves, the runtime behavior. So can I just go back for 1 second? My dereferencing then, if we look at the dereferencing me.name.first, if we look at that expression there, the expression me.name, that's now going to evaluate to, this entire object here. And so I am subscripting, I'm kind of indexing into a key called first. And so there is a key called first within that inner object. Okay. Sometimes when you have objects, because sometimes you see objects are things that you don't declare yourself, you actually, maybe you receive an object from another program or another function, or you even receive an object from a web API that it returns back a JavaScript object to you. It returns it back. It sends it across the wire in maybe JSON form or XML, and then it's converted into a standard JavaScript object. So the objects won't necessarily be objects that you declare using the literal syntax, which is all we've seen so far. So you may not be certain as to what the structure of that object is. And maybe what you want to do is you want to extract all of the keys within an object. How do I actually do that? So this is the syntax for doing it. So you go object.key. Object is a global construct within the language. Let's call it that. Technically, it's an object as well. It's a special kind of object that has a function called key. But if you use this expression and just pass it a reference to an actual data object, like the me object from our examples there, then what this expression returns or evaluates to is an array containing strings, and the strings are the actual keys within this object. So you now have an array of strings, and those strings are the keys associated with this object. What you want to do with that depends really, but that's how you can get at them. Alternatively, maybe all you want is you just want the values within an object. So this is the expression that you use. And this expression again will return an array where the array will have entries corresponding to the values within this object that you pass to it. This is kind of standard Java type syntax. I think you'll be familiar with. So, you know, we're calling, this is technically a method associated with this object, and this is the argument to the method. I've done that actually you can see me using it there. I've commented it out, but you can see it happening. Let's see. Yeah, those two lines there. You know, and again, you can just see what does this console.log actually output. You can play with that yourselves. The in operator, again, that was introduced in, I'm not sure it was ES6 or ES7 or where in the series, but the in operator allows you to write expressions like this. And now typically you would use this expression maybe in an if statement where you're checking to see, does a particular object have a key? So let's assume me is an object reference. And so what this expression is going to check to see is, does the me object have a key called name? And so it'll either evaluate to Boolean true or false. Reference 042 nested objects. I guess we're using them in there. 042. I have my name object again, my me object again, and console.log me.name. The first, that's okay. There's nothing new there. Where do I use the in operator?
Last two lines.
Last two lines. Oh yeah, thanks. Yeah. Just need to enable it for myself. Okay, so that should do a console.log of, does me have address? It does, I think. Yep. So that'll just console.log the Boolean true, whereas this one will console.log the Boolean false, because I don't have a password. The other way you can write that, which is the kind of old way of doing it, and again, I kind of lapsed into doing that, is let me get this right now. If you go me dot address equal to undefined. This was kind of the old way of checking to see whether an object has a particular key or not, because we remember it said if you try and access a key that doesn't exist in the object, then the expression evaluates to undefined. So here I'm checking to see, does this evaluate to undefined? If it does, then it means the address isn't in it, and if it doesn't, it means it does. So maybe what I really wanted to do was to not that. Well, no, you can just leave it as it is. So you can write it this way, or you can write it using the in operator. I think you'll see me accidentally doing this approach in the lab. The triple, why triple equals there? There is a double equals in JavaScript and a triple equals. Double equals is kind of frowned upon now. They both essentially do the same thing. They check for equality, but the double equals is not as safe as the triple equals. The double equals sometimes returns a true when clearly it should be a false, especially if you're trying to compare two things that are of a different type, but might have the same value. For example, if you compare the numeric value 0 with the string that contains the character 0, Double equals might return a true to say that they are equals, but really they shouldn't be because they're different types. Whereas the triple equals would return a false for that case. So never use the double equals really is the kind of message. Always use the triple equals because it is a safer comparison operator. It always makes sure that the two things that are being compared are of the same type. And if they are not, then it will return a false, which is really what you want comparison to do for you. A little known fact is this here, that internally within the JavaScript, there is no such thing. Sorry, is that the point I want to make here? Oh, yeah. Sorry, yeah, it's not actually, but just by the way, anyway, internally, how objects are stored in memory within the JavaScript runtime is that the keys are stored as strings. So like, it's not, like I say, no, it's not really that important, but like I'm declaring my object here with keys, but I'm not declaring them as strings. I'm just using, I'm not quoting them, sorry, but they're still going to be stored as strings internally. I could have, if I wanted to, I could explicitly make these strings, but it's just extra typing on my part. And usually it's very error prone because if you do something like this and you forget the closing quote, then you're just going to get a runtime error. So you don't have to, when you're declaring them, you don't have to say that they are strings, but internally they will be stored as strings anyway. And that's really why we have the subscript notation available to us at all. That's just, by the way, it's just something internally which you can duly forget, I guess, if you like. Moving on. This is an error that, here's my prediction, and I predict it every year, and I'm never wrong. This is an error everybody will get at some stage during this module, or a variation of it. And the error reads something like this: cannot read property of undefined. And undefined is this thing that I've mentioned once or twice to you. And it arises, I've tried to narrow it down to when does this error actually arise? And I think I've kind of narrowed it down to here. So first of all, I'm saying when you try and access an invalid property of an object, as in something generically like this, I've already told you this now, I've said that this expression evaluates to undefined, to the value undefined. Now that's not an error as such, that's just part of the language. However, if we interpret this to be a valid property and we then try to change something onto it, which is what I'm doing here. If I go some object dot bad property dot something else, now I am going to have a problem because I'm trying to access a property called property X of the value of the primitive value undefined, and the primitive value does not have properties associated with it. So this expression is now going to throw an error and your program is going to crash, and any code subsequent to this statement is not going to execute. If you've got this statement in your code, it's not going to crash. It's going to continue on executing as normal, in as far as it can anyway. Whereas this is where you get your fatal, and this is where you get the error of this form up here. So in the case of this one, it would say cannot read property X of undefined, where you're trying to access property X of the primitive value undefined. And this is how you kind of see it in the console. It won't appear in the web page, but when you open up your developer tools console, that's where you see your runtime errors. And just by way of illustration, I think I have not included this script in the samples that you get from the lab, but if I just quickly look at it. So we're moving on to here. And I'll just show it to you in the browser now, because even though you will get it at some stage, sorry, I need too many things open here now. Just won't save any of those. Right, back to index, and I want to disable this and enable this one, I think. Yep, and save that and go back to my browser. Okay, let's see what's inside in the actual script file. So same old story, my name object, my me object, and here I've got a console.log of me.finance.deposit. Now, finance does not have a key called deposit, okay? So this console.log is going to output undefined. Yeah, that's what we get. It's not a runtime error because it doesn't cause my program to crash because this console.log executes as normal. If I bring in this line though, if I think that me.finance is valid and I try to access a property within it called deposit, now this is going to throw a, me.finance at deposit is undefined, but if I try and access a property called bank of deposit, this entire expression now is going to throw a runtime error because I'm trying to access a key called bank of this object here, but of course it is not an object, it is the primitive value undefined. So I enable that line of code, I save it, and lo and behold, I get my runtime error, and the program actually crashes, and I know it has crashed because the very last console.log, which outputted the end, that's not appearing here at all. So you will get that error. Debugging it can be tricky. Obviously, it isn't in this case, it's pretty straightforward, but it can be tricky working your way back because what you need to discover is, well, why is this expression undefined? Is it because there's a problem with finance, or is there a problem with deposit, or where does it arise? I guess when we start getting these errors, that's when we can start understanding how to actually debug them. But for now, just be aware of the existence of the error and what it is telling us. Why it arose is another day's work. Other variations, yeah, if you have, so I've got var1, which is assigned to null, and then I want to go var1.property x, same problem, and try to access a key for something that is not an object. Null is not an object. Okay, that's objects. Obviously, any programming language worth its salt has to have the array construct, and JavaScript is no different. And arrays are declared using the same syntax that you're familiar to from any other language. So you use your square brackets and the individual values within the array. The values can be of any type, primitives, objects, or even arrays within arrays. You can have a mixture, so you don't have to have the individual types of the values within an array do not have to be all of the same type. They can be mixed. However, again, it's probably a reflection of poor design if you do have an array with different data types in its members. But it is, from a syntax point of view, it is allowed. And we access elements within an array using the kind of standard subscript notation, where the subscript is an index value and the indexing begins at 0. So it's all that stuff that you're familiar with from other languages. And you can look at script 05 yourself to see how we declare and reference elements within an array. Array data structures. Oh yeah, so this is the point I thought I was making earlier on, but it turns out, right, that from a syntax point of view, JavaScript does support the array structure, but internally it does not. Internally, the only structure it supports are objects. So when you declare an array in your code, what happens is that array is actually converted into an object where the keys are 0, 1, 2, 3, 4, 5, and so on. They're the actual string 0, the string 1, the string 2. Now, you do not, that has no consequence from a developer's point of view. You just treat them as if arrays were native to the language, but in fact, they're not. And it won't impact your development in any way to know that fact. I could have left it out, I suppose, but there you go. An array of objects, oh yeah. As well though, the difference, so when you declare an array, okay, it's converted into an object internally by the runtime environment, but that object has some extra properties added onto it because it originated from an array declaration. And some of these properties are, for example, you can determine the length of the array. You can add elements to the array, add elements to the end of the array or to the head of the array. So we call these utility methods like push, pop, shift, and unshift allow us to add and remove elements from an array, which is something that we typically want to do. You know, it's yeah, so these are just extra methods or properties, strictly speaking, that are available to us in an array structure. And I think I have, yeah, I'll just quickly flip over. So there's another script that demonstrates arrays. And again, you can, I've commented out various parts of it, and you can uncomment these things and save them and see what do they produce for you. But, you know, they're just all the things that I've been talking about. Obviously, when you've got arrays, then one thing you want to do is iterate over the array. The standard way of doing that is using a for loop. So we have the standard kind of for loop that you may be familiar with from other languages like Java. That's available to us in JavaScript. And there are other slight variations of that for loop that are unique to JavaScript. So we've kind of got this, what's called the for in, the for of, sorry, loop. There's also a for in loop. We'll see later on, though, that when we want to iterate over an array, we don't use the standard for construct. We use another approach, which is more commonly used in JavaScript. And we'll cover that when it arises. So again, you can look through that script yourself. It has various examples. Here you can see I'm doing things like manipulating the array, like pushing and popping and shifting and unshifting entries onto the array. So it's expected that you look through this yourselves in your own time. Okay, let's see. So all in all, when we've got the object structure and the array structure, really they are the only two structures that we need to define or declare any kind of complex data structure that we want to. No matter how complex a data structure is, those two fundamental constructs of objects and arrays will allow us to actually declare them. And so number one, being able to declare them, perhaps more importantly, being able to navigate them is what you need to be comfortable with when you're doing any kind of JavaScript code. So for example, I'm saying, supposing we've got an array where its elements are also arrays, then, you know, this kind of syntax here will allow me to access particular values. And this is just kind of classic two-dimensional array. Or if I've got an array of, if I've got an array of objects, then an expression like this makes sense. So array outer subscript 1, that expression, as we know, is going to extract the the second element in my array. But I've said it's an array of objects. So tagging on or chaining on dot property x means I'm trying to access a particular property within the second object entry in my array, and so on for the other ones. So from a programming point of view, I guess you just have to be comfortable writing this kind of chaining style, which I'm sure you've come across in other languages anyway. And our friend, the undefined error arises here. I'm saying accessing values inside nested array. Oh yeah, that's really where you will come across this error that I've been talking about typically, where you've got a nested data structure and the expression that you've coded is going to evaluate to undefined, and then you're trying to access something within that undefined structure, which doesn't make sense, and hence you get this error that I've been referring to every now and again. String templating, where are we on time? Okay, I suppose I've covered, let's see, sorry, let me just flip forward, see how many left, 2 slides, yeah. Okay, let's, I'll pause it here maybe because I've gone through at a fair old pace. So what you should try and do for, before the next lecture is to go to the website, and you have enough information now, sorry, where is it? You have enough information to be able to work your way through this lab here, maybe with the exception of the, I think you'll be able to work through all of it. Not sure if string templating is covered in this lab or not, but it's pretty straightforward, I hope, this lab for you, just to get you up and running. So it's more a case of familiarizing yourself with VS Code and that environment, installing a plugin, and then just some of the basics of the JavaScript language. That's the objective from a lab point of view for this week. And next week, then we'll start looking at functions, the other side of JavaScript. And once we've completed that, we can start into the frameworks that I mentioned there at the outset. So just before we finish, I suppose I should allow you an opportunity. I don't give you opportunities, I know, to ask questions, but as I said before, just feel free to butt in at any stage if you have any questions. Are there anything that you want to ask me before we wrap up? No? Okay, what I'll do is I'll put a recording of this up on the website if you need to fast forward to a particular part of it. So in the meantime, maybe just set yourself up from a software installation point of view, and I will touch base with you on Thursday. I'll just be available on Slack on Thursday. If we need to, then we can start up a Zoom meeting if we want to share screens and that kind of stuff. That'll be fine, but I'll just be available on Slack if you've got any questions of any nature, whether they be the labs or otherwise. All right, so I'll touch base with you on Thursday and talk to you again next Tuesday. Bye for now.